Okay. So, so now the idea is that I will take the whole system and I will apply on it the principle of work and energy. Okay? We were talking about the displacement, why B will go down and A will go up. Okay? Look, to know that B will go downward, you should do a small analysis. If you have equilibrium conditions, what should be the weight of B? So you can ask yourself, what should be the weight of B to have static case? In static case, you don't have motion. Okay? Look, if you do a small analysis, if I don't have motion, I have my system at rest. If I take block A is at rest, means that the weight will just do equilibrium with the tension in this cord. Okay? So in this cord, I have a tension T. In equilibrium condition, in equilibrium conditions, you have that the tension T should be just equal to the weight of A, which is equal to 10 times 10 equals to 100 Newton. Okay? Now, what should be then the weight of B? How do we can calculate it? Since you have the same cord, when you have one cord, the tension will remain the same at any point of the cord. Okay? So now if you isolate your block B and you want to find the forces acting on it, you have the weight of B. And since you are cutting here at 4 locations, at each location where you do a cut, you have a tension T. So you have T, 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 and T. So you have 4 tensions acting on B. So if you want to write equilibrium condition, so at equilibrium, we should have WB minus 4T equals to 0. So WB should be equal to 4 times T should be equal to 400 Newton. This means that the weight of B, the mass of B should be 40 kilograms. Okay? Now, in this case, the weight of B is 100 kilograms, which is larger than, the mass of B is 100 kilograms, which is larger than 40 kilograms. This means that no equilibrium will take place. And since the weight is larger than what is needed for equilibrium, then B will be able to move down and A will be displaced upward. If you put a mass here smaller than 40 kilograms, then A will go down and B will go up. Okay? So the equilibrium state will tell you what is the limit. When for 40 kilograms I have equilibrium. For a mass larger than 40, B will be dominant, it will move down and A will move up. While for a mass lower than 40, B will move up and A will go down. In this problem, you are in the case of mass of B higher than 40. So B will be displaced downward and A will go up. This is why VB will be positive, and it's given here. They gave you that at the final state, VB2 is plus 2 meters per second. And you found a relation between VA and VB. So VA2 is minus 8 meters per second. Now you know the velocities, which is good. What you want to find is the distance moved by B. So if you want to find delta S of B. This is your unknown. Now, what is good that you have also a relation between delta SA and delta SB. So you can relate the displacement of A and the displacement of B. The relation is, as we have found, delta SA is equal to -4 delta SP. Okay? So now, all I have to do is to write the principle of work and energy, to replace VB2 and VA2 by their values, and the only unknown will be delta SB. And from here, we can calculate the value of the displacement of. So, if I write the principle of work and energy, the only forces doing work, as we said, are the weight of B and the weight of A. So we can write the following. We can write work of WA plus work of WB equals to sum of kinetic energies. Because why I put a summation? Because your system includes 2 blocks, not 1. So I should take the summation of kinetic energies at state 2 minus the summation of kinetic energies at state 1. Okay? And now I will start to express my terms. Please remember, when you have a downward coordinate, what is the expression of the work of weight? It's plus mg delta S. Keep in mind, if the axis is up, the expression is minus mg delta Y. Here, since you consider downward coordinates, so the work of the weight for each block is plus mg delta S. So for block A, the work will be plus mg delta S of A. And for block B, the work of the weight will be plus mb times G times delta S of B. Now please pay attention. Delta S can be positive or negative. Since B is moving down, delta SB is positive, so the work of the weight of B is positive. And this is expected because when you move down, the work of the weight will be positive. While for A, delta SA is negative because your block is moving upward. So when you calculate mg delta SA, you will get a negative work since the displacement of the block is up. Now, since you have a relation between delta SA and delta SB, and you want to find what is delta SB, you replace in this equation delta SA by -4 delta SB. And then your only unknown in the first side is delta SB equals to. For the second side, what do you have? You have sum of kinetic energies at state 2 minus sum of kinetic energies at state 1. Your system is starting from rest. This means that summation of kinetic energies at state 1 is 0. So the only term that should be accounted for is sum of kinetic energies at state 2, which is equal to the kinetic energy at A at state 2 plus the kinetic energy of B at state 2. Now, since we know the velocities at state 2, we can easily calculate the kinetic energies. So it's half MA VA2 square. And we have seen together that VA2 is -8. So since it's square, I just put it 8 square. Plus half MB VB square. And VB is equal to 2. So times 2 square. So as you can see, the only unknown in this equation is delta SB. So I can calculate delta SB. And this is the required. They want us to determine the distance traveled by B. Any question on this problem? questions? Do you want me to repeat anything? Okay, so we are done for today. We'll continue next time. I will send you this PDF, okay?
Okay,
Bye.
thank you.
Merci.